So our next question is from Gil. Can Jenny elaborate on the biology that can make silica and iron available, and any suggestions on how to encourage in an indoor setting?
Okay.
Wow.
Not all biology breaks down silica. In general, it does, but not all biology. So adding, I mean, if you're going to do an indoor grow, many times in a small space, people add monosilicic acid because on large scale, it's not budget friendly. But monosilicic acid in indoor grows, if you wanted to do a trial and see if that was something that would work for you, that is available. Silicic acid is silica available for plants. I don't know the biology that makes silica into silicic acid, but in general, the trends in sap analysis, and so tissue you cannot test for silica because the acid destroys it. So that's why silica isn't on a tissue test, because acid is used in that analysis. But in general, that's what I said. But people that are biologically improving their soils, not by neglect, but by inputs, cover crops, things like that, their silica increases, and there is usually 100 part per million or more difference between the silica numbers, which is pretty great. Like a dead soil is like, 7, 10, 15. Organic is usually 120, 160 higher. So it's a pretty big difference. But in general, a lot of if you're going to be using a biological input and you're using diversity, you're going to have at least one that's breaking down silica, if not more. Will all of them? No, they will not. But your silica numbers should increase, and your iron should increase as well. So that is, they're making it, manganese should increase. If you're using bacteria along with beneficial soil fungi, you should also see a nice little jump in phosphorus in a few months. It's not going to be in a few weeks, because you're adding spores that need to sporulate and grow hyphae. And that's how the phosphorus is. That's a macronutrient increase. So along with other things as well. Did I answer the question? I forgot it.
Say again.
Did I answer the question? I forgot the whole thing.
Yes, you absolutely did answer the question. And I love the way you said biology, as well as some of these other practices like cover croppings, is the key to the whole thing. And the only thing I'd like to add to that is, if you are going to use biologicals, it's always easy to go buy the bugs in a jug, especially now you're seeing, like, God, all the big ag companies are selling bugs in a jug. Now, they do work. They will release short term, but unfortunately, you're not colonizing. You're only giving it a bump for a short period of time, and then you have to go back and reuse it again. So how to get those long term so they colonize? Well, that's where it comes into making biologically complete compost. Anybody can do it. You can liquefy it. You can spray it on the plants. You can spray it on the soil, and that's going to give you that long term bump, so that you're not going to have those kinds of issues that you're talking about, short term issues versus long term issues. And as far as like trying to get iron, it'll be released from the plants that are being degraded in your compost, because they're all going to have it in them. Now, if you're trying to do like a startup and you're going fresh in, just make sure you're using a chelated iron, because that's really important. That's going to be a lot more friendly to limited microbes, because they'll still be able to break it down to some degree. Whereas unless you have what we call degraders, which again will come from a really good biocomplete compost. If you don't have degraders, they can't break off those first couple electrons so that you can start to release them or soften the iron out of the mineral form. Like phosphorus, organic phosphorus, forget it. It's locked up rock hard. The only thing that can do it is the acids that come from mycorrhizae. Saprophytic, even their acids aren't strong enough to mine phosphorus in an organic form. Again, that's why we push these kinds of products, these biologicals, so that you do get the potential out of your soil system, your soil solution. And this goes back to that real interesting fact that phosphorus in the soil is not a problem. It's only when that phosphorus comes in contact with aquatic water, that's where you get the phosphite solubilizing bacteria, that every single piece of organic phosphorus is instantly released into solution. Then you get the algae plumes and the die-offs and the degrading of water systems. But I thank you for answering that. It was wonderfully put, Jen.
And
the phosphorus bound up in biology does not break down. So you have it bound. So the more biology you have, aquatic water doesn't come into play, which is nice.
Yes.
It's all about the biology.
Well, unless you're using fish brew.
Oh, okay. Yeah, a caveat on that one. Yes. And Gil says, thank you, Jenny.
You're welcome.
So not so much of a question.
Yeah, that one wasn't a question.